Ever wondered why the microscopic world behaves so differently from the world we experience daily? Well, that's where the fascinating field of quantum physics comes into play. It takes us on a journey into the realm of the ultra-small, the domain of atoms and subatomic particles, where the ordinary rules of physics no longer apply. Quantum physics, in essence, is the branch of physics that explores this enigmatic microcosm. It delves into the behavior of particles on the quantum level, which is scales so small that they're practically beyond our comprehension. Imagine a space so tiny, even a single strand of human hair would seem colossal in comparison. This branch of physics is a radical departure from classical physics, which you might be more familiar with. Classical physics, with its laws of motion and gravity, does a splendid job of explaining the mechanics of our everyday world, from the arc of a thrown ball to the orbit of planets. But when we venture into the quantum realm, these laws start to lose their grip. Instead, quantum physics presents us with a world that is governed by probability and uncertainty. This means that we can't predict with absolute certainty what will happen, but only the likelihood of different outcomes. It's a bit like rolling a dice. You can't be sure of the number you'll get, but you do know the possible outcomes. This inherent uncertainty might sound a little unnerving, but it's one of the fundamental aspects of the quantum world. It's what allows for some truly mind-bending phenomena like quantum superposition, where particles can be in multiple states at the same time, and quantum entanglement, where particles become interconnected in such a way that the state of one can instantly affect the other, regardless of the distance separating them. So what makes quantum physics so strange and fascinating? Well, to start, imagine a world where the ordinary rules of reality don't apply. A world where a particle can be in two places at the same time. This bizarre phenomenon is called quantum superposition. It's a bit like if you could be at home and at the grocery store simultaneously. Sounds impossible, right? But in the quantum world, this is business as usual. Now let's take another leap into the peculiar world of quantum physics. Ever heard of spooky action at a distance? This is what Albert Einstein famously called quantum entanglement. When two particles are entangled, they become linked, and the state of one instantly influences the other, no matter how far apart they are. It's as if, by some mysterious connection, if one particle were to suddenly start doing the cha-cha, the other, even if it's light years away, would instantaneously start dancing the same jig. But how does this all relate to us living in a world governed by classical physics where particles can't be in two places at once, and actions don't have instant reactions across vast distances? Well, the answer lies in the fact that we're made up of these very quantum particles. And while our day-to-day experiences might not obviously reflect the peculiarities of quantum mechanics, these strange phenomena are essential for everything from the structure of atoms to the stability of stars. Quantum physics is like a window into a world where the rules as we know them get completely turned on their heads. It's a world that's strange and fascinating, and one that we're just beginning to unravel. It's like stepping into a magical realm where particles can be in multiple places at once and influence each other from light years away. Quantum physics might sound like science fiction, but did you know it's part of your daily life? Yes, you heard it right. Even if we're not aware of it, quantum physics is at play in numerous aspects of our daily lives. Let's delve into a few examples. Consider the modern marvel of technology, the smartphone. It's a device we can't imagine our lives without, but did you know that the functioning of your smartphone relies heavily on quantum physics? The semiconductors in your phone, which are essential for its operation, are based on quantum mechanics. These tiny devices exploit the quantum nature of materials, allowing electrons to move in a certain way to facilitate the flow of current. Now let's talk about something as commonplace as light. The lasers in your DVD players, barcode scanners at the grocery store, or even the fiber optic cables that bring you high-speed internet, all of these rely on the principles of quantum physics. Lasers, for instance, work on the principle of stimulated emission, a quantum mechanical effect where a photon, or a particle of light, interacts with an electron in an atom, causing it to drop to a lower energy state and emit a new photon. Even the natural world isn't immune to the touch of quantum physics. A process as vital as photosynthesis, through which plants convert sunlight into energy, has a quantum twist to it. Recent research suggests that quantum coherence, where particles can exist in multiple states simultaneously, might play a crucial role in the efficiency of photosynthesis. And let's not forget about the marvel of quantum tunneling, which is responsible for the nuclear fusion in the sun, the very process that keeps the sun burning and gives us light and warmth. So as you can see, quantum physics isn't just about the mysterious and the abstract. It's integral to the technologies we use, the light we see, and even the life we live. In essence, without quantum physics, modern life as we know it would be dramatically different. Quantum physics doesn't just change how we see particles, it changes how we see the universe. As we delve deeper into the realm of the infinitesimal, we find that the universe reveals itself in unexpected and fascinating ways. Quantum physics, with its concepts of superposition and entanglement, forces us to rethink our understanding of reality. These concepts are not merely theoretical musings of eccentric scientists, they are backed by rigorous experimentation and observation. For instance, let's consider the famous double-slit experiment. When particles such as electrons or photons are fired through two slits, they create an interference pattern on the screen behind, as if they were waves rather than particles. But the real surprise comes when you fire these particles one at a time. Even then, an interference pattern emerges. This suggests that each particle, in some sense, goes through both slits simultaneously, as if it is in two places at once. This phenomenon, known as superposition, is a cornerstone of quantum physics. In another astounding revelation, quantum physics presents us with the concept of entanglement. Imagine two particles created together and then separated, even by vast cosmic distances. According to quantum physics, a change in the state of one particle will instantaneously affect the state of the other, no matter how far apart they are. This spooky action at a distance, as Einstein called it, challenges our everyday notions of space and time. The implications of these quantum phenomena are profound. They hint at a universe that is deeply interconnected, where particles can exist in multiple states at once, and where the fabric of reality itself is woven from uncertainty and probability. This is not the clockwork universe of classical physics, but a wild, wacky, and wonderfully weird quantum universe. The exploration of quantum physics is akin to venturing into a surreal landscape, where the rules of the game are as elusive as they are enchanting. It's a journey that takes us beyond the confines of our everyday experiences, into a world where the impossible becomes possible. Quantum physics peels back the layers of reality, revealing a universe far stranger and more mysterious than we ever could have imagined. As we venture further into the quantum realm, what future developments can we anticipate? Well, the potential applications of quantum physics are as vast and varied as the quantum world itself. In fact, we're already witnessing the dawn of quantum technologies that promise to revolutionize various sectors. One of the most exciting prospects is quantum computing. Traditional computers use bits, ones and zeros, to process information. Imagine instead a computer that uses quantum bits, or qubits. Unlike regular bits, qubits can exist in multiple states at once, thanks to a quantum phenomenon called superposition. This could allow quantum computers to process massive amounts of data at speeds unimaginable today. We're talking solving complex problems in seconds, problems that would take today's fastest supercomputers millions of years to crack. Then there's quantum cryptography, the use of quantum mechanics to secure data transfer. It's based on the principle that the simple act of observing a quantum system disturbs the system. So any attempt to eavesdrop on a quantum encrypted message would immediately be noticed. This could lead to virtually unhackable communication systems, a much-needed advancement in our increasingly digital and security-conscious world. But the implications of quantum physics aren't limited to computing and cryptography. It could also lead to breakthroughs in fields as diverse as medicine and material science. For instance, quantum sensors could detect disease at its earliest stages, or monitor brain activity with unprecedented precision. Quantum materials could pave the way for superconductors that transmit electricity without loss, or ultra-sensitive detectors for use in technology and research. So, while the quantum realm may seem distant and abstract, It's a frontier of untapped potential, poised to shape our future in ways we can barely imagine. The quantum world may be strange and counterintuitive, but its exploration could be the key to unlocking unimaginable technological advancements.